We'll continue our session with Wolf Vollprecht, CEO at Prefix Dev. This talk is very interesting. We're talking about Python packaging and especially how to do Python versioning in a changing world. So very interesting about the content. The stage is yours. Please welcome Wolf.
Thank you. Thanks for the nice introduction. I'm going to get started with a little about me. So yeah, I'm the CEO of Prefix right now. And before, I've worked a lot on Mamba. And we're still doing that in Prefix. And also contributed a lot to CondaForge. I'm a core member of the CondaForge team. There's another pet project of mine, which is called RoboStack, where we're trying to package a lot of packages necessary for robotics as conda packages. And now at Prefix, we've kind of rewrote things a little bit and came up with a new library that's called Rattler, which is a Rust implementation of all the conda package formats. And we've been launching a new product or project just yesterday, which is called Pixi. It's a kind of a new take on conda package management that follows a bit more of a workflow approach. And we launched it at EuroSciPy because EuroSciPy is actually a special event for us since we met for the first time in person as the Prefix team last year at EuroSciPy. So yeah. And yeah, we've really tried to build a cool project with Pixi, and one of the most interesting things is maybe that we're going to try to work on a pip resolver as a next step. So let's see how that goes. And that work also inspired a little bit this talk. So first, I want to start with versioning schemes. There are a bunch of different ones, and Jacob Tomlinson, I don't know if he's here right now, but apparently they had a heated discussion yesterday. That's why he tweeted something today, and he's also at this conference. Yeah, so basically, Calver and Semver, and Calver is the odd one that just says Happy New Year. So we're going to learn more about this right now. So what are semantic versions? With semantic versions, you basically have three components. More or less, one is major, minor, and patch. And the rules are that you should increase your major version when you make an incompatible API change. You should increase your minor version when you add functionality in a backward compatible manner. And your patch version when you make a backward compatible bug fix. But getting semantic versioning right is really tricky, because often you don't really realize how backward compatible the things that you're doing are. So it's super backward compatible if you just add a new function, for example. But as soon as you change, for example, how an argument in some function is interpreted, or if you add or remove arguments, it's already not backward compatible anymore. So I think most libraries should probably release major versions much more often than they do. And then there is this hot contender that's called calendar versioning, where you just take the day of your release and stick that into a version number. And very famous projects that are doing this are Ubuntu with their LTS releases or just generic releases. And it's very easy to identify which one is an LTS release and which one is not. And you also always know how up to date you are with your distribution. And then Certify is another one that's widely used for getting certificates on your system, where it's also pretty critical to know how old are your certificates and how recent. And then basically the advice that is maybe passed around on the internet is that Calver is pretty good for applications and distributions. So if you have something that is a proper application that you ship to users, it's quite informative to use calendar versioning. But semantic versioning is still good for libraries. And now I wanted to talk a little bit about a couple of Python versioning quirks. I don't know if you know all these different elements that you can have in your version. And this guy, Cez Larsen, did a pretty cool blog post where I stole a few of these One really important element or interesting element if you want to switch from caliper to semver or back is the epoch, which allows you to completely change your versioning scheme by just putting a 1 exclamation mark or 2 exclamation mark and so on. And so if you at some point decide to go to caliper and then you really want to go back, then use the epoch and you have a way out. There's also some interesting quirks, like if you didn't know, but the zeros are just like removed, that are in front of the number is treated as an integer, everything between the dots. There's no maximum length in Python versions, and there's a cool gist somewhere on the internet. And one version number just took like the first 200 something letters of pi. So the version is 3.1.141 whatever. Pretty impressive. And then you can also combine pre, post, and development versions in your package. So if you're into that, very confusing. But who needs versions anyways? So versions are really necessary to communicate with the users, to get them to know basically that they are on the latest version, and then also with fellow developers. And that's where I think semantic versioning kind of shines, because it signifies that you did something in your library that you think is an API break, and they should like take care when they upgrade. And whenever you release a major feature, yeah, it's kind of nice to be able to bump the major version of your library as well. And that is usually always good for a tweet or a blog post and stuff like this. So a lot of people are pretty careful with major versions. And then the other big reason to have version numbers is obviously to use them in constraints, so that other packages, applications, libraries, whatever, can actually say, okay, I depend on that minor version, or my lower bound is that, and my upper bound is that. Like here with this foo example. And that is the next topic that I wanted to talk about, so upper bounds and their peculiarities. And there's a super heated debate of whether you should or should not have upper bounds. And lots of projects got recently bitten by not having upper bounds, but at the same time, having upper bounds is also pretty annoying because you can't really override them. And if you have some package in your entire tree that has an upper bound, it like holds everything back, basically, or it can hold everything back, depending on what it does. But for example, like in some project that I'm working with, there was a urllib3 release, and that basically removed some attribute. It removed the strict attribute from HTTP response, and that like just broke the project. And if that project would have an upper bound in urllib3, then it would have worked. And then pedantic also got recently released, the 2.0 version got dropped. And these dependencies are used in many different projects, and that makes it have like a really big impact if there's no upper bound. And so the pedantic case was one that I heard was that basically pedantic 2 got split into 2 packages, pedantic and pedantic settings. And then if you use pedantic settings with pedantic 1, you can't really depend on pedantic 2 because you would also have to add pedantic settings to your dependencies. And then pedantic settings doesn't exist with pedantic 1, so that's a pretty nasty way of breaking compatibility. And then there are different ways in the conda and the pipi world on how you can kind of fix this. And I think, as far as my knowledge goes, in the pipi world, you just have to release a new version that either adds a new lower bound or upper bound or something like this. Or you can ask your users to downgrade specifically that one package to that older version. Or you can use a log file and then kind of roll back to the previous log file or things like this with poetry. But in the conda world, we actually have a different mechanism, which is called the repolator patch. Because one big difference in conda and pipi is that conda has a central index file that's like a huge JSON file with all the packages and all the dependencies. And we can patch that file and add a new upper bound. For example, we could just say everything that depends on pedantic up to this date cannot work with pedantic 2.0 and beyond. And that's one way to kind of fix the things after the fact. which is interesting. And then the other thing that you can do is you can use conda log or Pixi to also create log files like poetry, and then roll back to that log file if you want. And then I had a bunch of discussions about this, and also with one Python library author, Martin Brettels, and his opinion is basically to never use upper bounds, and that libraries should be infinitely backwards compatible, and you should basically never change anything after you hit some sort of popularity, and really resist the urge to ever clean or remove things from your library. And then obviously you should make liberal use of the deprecated thing and maybe give like 6 months or so ahead of time of deprecation warnings. But yeah, as I said before, for an app, it's also good to use caliper. And now basically at Prefix, we've been thinking about this problem a lot. And we've been asking ourselves, because that conda mechanism somehow makes sense, to be able to kind of like after the fact change the dependencies and make sure that things stay compatible, because in my opinion at least, you're guaranteed, if you don't have any upper bounds, that at some point installing that old version without any log files or any other mechanisms, you will get like incompatible versions, and then you have this really tricky task of figuring it out. And so basically our idea is, can we detect API or ABI changes automatically? And ABI changes are something more for like C libraries and stuff. And then also, can we automate the process of figuring out like the appropriate upper bounds? And can pipi metadata maybe be patched too? And so we did a bunch of experiments, I want to say, using different tools. And before us, there was also another group working on this to do static analysis of the Python code and basically figure out what are all the symbols that are imported by this library and how are all the functions used. And on the other hand, what functions are exported from that library and symbols exposed. And turns out it's pretty difficult because Python is a super dynamic language. But there are some, I don't know if you can read this, but this is basically an index that is on GitHub. It's a JSON file that contains all the conda forge packages and then all the symbols that it exposes that are starting with AZ. So it's Azure. And then we also tried a little different approach using a library called caliper, where the idea is to basically run the tests of that of the package that we have and do a dynamic tracing of all the functions that are exposed and all the constants that are used in classes and imports and exports. And I think that's probably a better idea for this kind of thing because, yeah, Python is just too dynamic. And this, if one runs caliper, one gets this similar exports and imports and all the symbols. But maybe this is all just too tricky for Python, and maybe the best idea is to just run the tests of the downstream dependencies and then see if they break, and if they break, somehow have a process of dynamically adding upper bounds and make them overridable by users. So that is probably what we at Prefix are going to try doing over the next year or so to make sure that all the version ranges are as good as they can be. I had a little excursus here where in another world, basically in C, C++, we have ABI problems. Those are also serious problems. I don't have much time left, so I'm just going to click through the slides. But basically for OpenSSL, you can see that it's also important to track how many symbols are there and how they are changing over time to make sure dynamic libraries stay compatible with each other. And then in for the Rust, there's a cool tool that's called cargo symbols check, which basically goes through the library and figures out using the Rust doc project, so whether things are actually semantically compatible in that sense and backwards compatible. And yeah, basically what I already mentioned, our idea is that semantic versioning is too hard. No upper bounds guarantee you that you will have some breakage at some point, at least in my opinion. We have to make it easier, and then our vision is that we have sort of a system with dynamic upper bounds that we figure out through test execution, essentially. If you want to talk more about this, there's a conference that I'm co-organizing, which is called PackagingCon. you can grab early bird tickets. It's in October 26 to 28 in Berlin, so not far from here. And I'd love to see you there. Looks like some people have the cameras out, so I'll wait. We also just launched Pixi, like I mentioned before, and we have a little happy hour tonight where we're paying for the drinks, so if you want to drop by, you can register now and get one of the few remaining spots. And I think that's it.
Thank you, Wolf. It was very informative. Are there any questions from the audience? Or is there... Yes, there is a question there. Two.
Hey, well, thanks. Thanks. Good talk.
Thanks.
You made a mention of this, and I'm curious about if it's just about changing people's perceptions. But we do try to hold to semantic versioning, but it means that we, oops, we broke something again, time for new major version. And I think people see like version 18 of something and they get freaked out. Like somehow that there's this idea that like that's somehow less stable because it's a higher number. And I just wonder if you have thoughts on how to counteract that impression, or if we're on the wrong base and we should be switching epochs all the time or something.
Yeah, I was also wondering that, and I mean, Firefox and Chrome, they've basically started to blaze through the version numbers like crazy, and I think they're at 100-something. So maybe we should just all follow that model and be less, basically spend more major version numbers. And, we could try.
Yeah, great talk. So by depending on people by depending on like test execution, you're depending on people writing tests. And I'm just wondering if you think that's a more tractable problem than the bounds problem.
Yeah. I think it's not just writing tests, because maybe you somehow import some constant from a library that's gone, and that's not really covered by the, it's implicitly covered by the test because you're also executing something, and then that falls apart already at the import stage. But yeah, definitely that's a downside. I wish it would be easier to do static analysis on Python, but it seems like also really hard to track. Yeah, not really a tractable problem. But yeah, I'm not convinced for Python to do it that way, but some dynamic component we need, I think. Oh, sorry.
Okay. Python itself, it also not the semantic versioning. So we still have Python 3 dot something. And the next thing which I think which make a lot of discussion is Python 3.20. Are you safe for this? Because we also say always number, version number, but it's a string, so usually.
Yeah. Yeah, the 3.10 already gave some problems actually in the conda project because it was interpreted as a 3.1 somewhere. So yeah. I guess Python is a big enough project to have their own way of doing versions, and everybody kind of understands it by now. Yeah. I guess we're safe enough, I hope.
Thank you. Are there any other questions from the audience? Okay. So thank you again, Wolf.
Thank you.